Welcome back to class time. Who's ready for some mathematics? I hope you are. I am Karima Mundell Thomas.
And I'm Richard Montague. And today's topic is direct and inverse variation.
And so let's get into our topic. The focus for the session is, so by the end of today, you should be able to represent direct and inverse variations symbolically. You should also be able to solve problems involving direct variation and inverse variation. So let's get into the lesson.
All right, let's look at a new taxi system that is about to start. Now, that taxi system is going to charge $20 per kilometer traveled.
Wow, $20. You know, Richard, I think we need to do some calculations here because I want to see how much I'm going to be paying for a certain number of kilometers traveled. So let's take a look.
All right, let's examine it together.
All right.
All right, so at 0 kilometers, we will have to pay nothing at all.
That's right.
Yeah. So 1 kilometer, we go right up $20.
Yes.
2, $40. 3, $60, and 4. You know we're going to be paying $80 right there.
Interesting, you know? This sounds like a business I want to go into. But anyway, let's not get into that right now. I have some questions, you know, that I really want to ask our students this morning. What is the rate of change of the cost?
All right, students.
What is the rate of change? So let's bring back up our table on screen, and we're going to be looking at this to see what's the rate of change. Any ideas, Richard?
All right, let's look at it together. And in examining the table, we recognize that each kilometer we're increasing by $20. Yeah.
Very good observation. I like that. So we're seeing that each time we go up 1 kilometer, the cost is increasing by
$20.
$20. You are right on the ball. So it is definitely increasing by $20 each time. I have another question. You know, I'm full of questions today.
I know that.
All right. So what I want you to write or think, students out there, I want you to write an equation for the total fare.
Charge.
That is charged for X number of kilometers. So we're using Y to represent the total fare,
Yes.
and we're going to be using X to represent the number of kilometers.
All right, remember your variables, students.
So, Richard, I'm looking at this, you see?
Okay.
And I heard you were saying something earlier about it's increasing by $20 each time.
Yes.
And I'm also looking at the table, and I'm seeing that for 0 numbers of kilometer, we pay $0.
Yes.
You know, I think I know the equation.
I believe so.
And
Students, you have it written down?
I hope they do. So let's bring it up on screen for them. So it's Y equal 20x. Did you get that?
I know they did.
All right. So we're talking about direct
All right.
and inverse
yes.
variation.
But we're on direct.
Yes.
So now, Karima, does Y vary directly as X?
That's a very good question, you know, Richard. But, you know, I think I need to find out a couple of things before I answer that question.
Let's go.
All right, so I'm going to ask my students out there. First question. Make sure you're on the ball now. First question. Is Y a constant multiple of X? Tell me what you think.
Okay. Most definitely our students know that out there in TV land. And your answer is? Most definitely it is.
Yes. Beautiful. And we notice that each value of Y, we get it by multiplying our X by 20. Yes. Beautiful. But I have another question because can't answer if Y varies directly as yet because I need to know something else. So what will happen when we divide Y by X? What will happen when we divide Y by X? And I'm going to bring up the table on screen because I want our students, make sure you have your pens, make sure you have your books, and ensure that you're taking this table off. And we want to see what's happening when we divide Y by x. So let's look at the first part, Richard.
All right, let's do that.
So we see y here is 20.
And when we divide 20 by 1, we end up with 20 students, correct?
And I think all our students are comfortable with that one. Let's look at the second one. What about when y is 40 and x is 2? If we divide y by x, what is it that we're seeing there?
I recognize we still get 20.
That's an interesting observation. I wonder if it's going to happen for the third one.
In TV land, students, what do you think we're going to get? Of course, that's exactly what we got.
You know, this is very interesting. Very interesting. Can you imagine? The y values are changing, the x values are changing, but every time
we have that constant coming on,
we divide y by x, we're getting that constant of 20. You know, this is very important. So I want to stop right here and I want to, clear up a few things.
Okay.
So the answer to the question, does y vary directly as x, is a resounding yes. And how do we know this?
Okay, because we're seeing that there's a constant that's going there.
All right, so we see that y is a constant multiple of x.
Yes.
That's one way of putting it. And we also see that when we divided y by x, we ended up with a constant of 20 every time.
Yes.
So I'm looking now, Richard, and I'm seeing that as the size of my x value, or the magnitude, we would say, same thing. As the size of the x values are increasing, I see the size of the y values increasing. But that's not the only thing. They must be increasing in such a way
that they are similar. They are the same size, same magnitude that's increasing.
So they are increasing in such a way that if I divide y by x, I'm getting that constant value.
Proportionality.
That's proportionality. So they are right. So they are increasing proportionally to each other. Good. So we can't just take things and say, oh, this one is increasing and that one is increasing. So
it must be increasing proportionally.
Good. So we have to do our checks and ensure that when we divide y by x, we're getting it remains constant.
All right.
So I think now our students know what it means to vary directly. So let's clean up the language a bit now. Let's focus a little on that. All right, because it's math class, but language is important.
Okay.
So we can say, when we find this happening, when we find this relationship happening, we can say that y varies directly
as x.
As x. Or we can put it another way, Richard. We can put it another way. We can say
y
that
is directly proportional to x.
All right. Y is directly proportional to x. Beautiful. So, we're in math class, not true?
There's something I want you to bring up, Karima. It's about the symbol, because so many times the students are not seeing the symbol coming with the language. So let's bring up the symbols and let's look at it.
All right, so we know that math has to do with symbols, not true? So we talked about the language and now we're getting into the symbolic language. How do we represent y varies directly as x?
All right. Here's the symbol, students in TV land. Let's look at it. So when we're seeing it, we know that is, or we're reading it, y varies directly as x.
Or we're saying y is proportional to x. All right, so y is proportional to x. What does that mean?
All right, what it means is that you have your y is equal to some constant times x. And that is something that we want all students to note. All right, whenever it is that we're looking at something that varies directly and sometimes indirectly, it's always some constant that's being multiplied. All right, so in this case, the constant is k being multiplied by x.
All right, so whenever we see this representation, y is equal to kx, we know we're talking about a direct variation. All right, definitely. So y is proportional to x.
All right, Karima?
No, I want to bring out something just before you jump in, Richard.
Lovely. This is where you were going?
Yes. Oh, my, you read my mind. Go ahead.
All right. All right, so we want students to know that k is not equal to 0, and k cannot be equal to 0 when you're dividing. All right, so when you have that y being divided by x, and it's equal to k. K cannot be equal to 0.
All right, but before we get to that point, I want our students to understand that y being equal to kx, as mathematicians, we know how to transpose, not true? We know how to change the subject of a formula, not true?
All right.
Yes, man, we know. And so if we're looking at this and we divide through by x, we're seeing what we noticed earlier, that y divided by x actually gives us that constant k. And I'm glad that you pointed out that k is not equal to 0. I just want to jump and piggyback on that to let our students know that k can be negative or it can be positive. Don't want them to think anything else. It can be negative or it can be positive. And k has a special name. Yes. You want to tell us what the name is, Richard?
All right, it's coming up on screen, and it is the constant of variation or the constant of proportionality.
All right, so it's the constant of variation, constant of proportionality. Now, I want our students out there, tell me, I'll hear you, just tell me, can you think of any other situation in which variables are directly proportional? Can you think of any?
All right, Karima, one comes to mind almost instantaneously, and that is circumference. Whenever I'm thinking about circumference, I'm thinking that you have your circumference is equal to your diameter times some constant.
What's that constant, Richard?
That constant is always pi.
Pi. So let's look a little closer at this equation. And I'm sure our students, they know this, that circumference is equal to pi multiplied by diameter.
Yes.
Right? Now, remember earlier we had our equation where we said y is equal to k, which is a constant,
yes,
multiplied by x. And I'm seeing that same kind of relationship coming out here.
Yes,
so my k here is pi. That
yes,
constant value is pi. Did you get that, students? The constant value here is pi. Richard, can you think of any other?
Well, I used to work at one point, and my wage was directly proportional to the amount of hours that I worked. So I'm thinking that is not another example.
I agree with you. That is indeed another example. So I think we're ready for some examples. I think you are ready for some examples. So let's look at this one quickly. If y varies directly with x,
and k is equal to 0.5, we must find the value of x when y is equal to 8.
All right, Richard, I'm noticing here that the value of k has been given, and we also have a value for y. Now, let's see. We would have learned this symbol earlier, that y is proportional to x. And we know that this means y is equal to
some
k.
constant times x.
Beautiful. So let's do our substitution quickly. So we have our y value, which is 8. And our constant is 0.5, and it's multiplying x. I know that my brilliant students out there, you know how to get x by itself.
Yes, in TV land, students, what we're going to do right away, we're going to have to divide both sides by what? Yes?
0.5.
Yes, in TV land, I heard you.
And so x is equal to 16. So note that when x is 16, y is equal to 8. I think we're ready for another example.
All right.
Let's jump right in.
And I'm loving this example. Now, if y varies directly with x, we're asked to find the missing value of x. And we're given, not k this time, but we're given a pair of x and y values. So we have -3, 27, and x and -18. So we're going to have to be using the pair that has -3 and 27.
Okay, so rightly said, we didn't have k, but we know how to find it. Now, these that we're looking at are some ordered pairs, Richard. So let's just bring up our equation quickly. We know it's direct, so it's y equal to k multiplied by x. We're substituting here. In the ordered pair, we know, and I know the mathematicians out there, those budding mathematicians, we know that in our ordered pair, the first value is our x. So we have that -3 as x, and we have that 27 as y.
The y value.
So let's do some quick substitution.
All right.
All right, so we have here 27 is equal to -3k, and this is a breeze. Our
Most
students
definitely.
have
What's
been
the
doing
answer,
this.
students? In TV land? Yes, you are correct. It is -9.
Oh, I was about to ask you how you know. What's the answer? I didn't hear it. All right, fine. So k is equal to -9. Now you notice that we divided by -3 on both sides.
Yes, we
now,
did.
Are we finished?
No,
Oops,
we are not.
How do we know that, Richard?
Because we have not yet answered the question. The question was, find the missing value of x. And at times, students, we sometimes just find the constant and then we figure that we've ended the question. No, we need to go back and make sure that we have answered the question.
Very good point. So we are finding the missing value of x. Now we know the equation that we're working with. Now that we have found k, we know it is y equal
some
-9. No, it's not just some constant. No,
that
we know the constant
is given, so we know it.
We know it now. So it's
Yes.
y equal -9x. Beautiful. And again, we're looking at our ordered pairs.
But this time we're using x and -18.
All right, so we don't know what x is, but we know that y is -18, and we can quickly substitute.
All right.
And we have it on screen. We're dividing through by -9.
All right, 2 seconds, students. And your answer is correct. It is 2.
2 seconds. You're cracking me up. All right, so we know that x is equal to 2. So when x is 2, y is -18. Now I see a scenario coming up on screen, and I love scenarios.
All right, so there's a distance from town A to B, and that distance is 60 kilometers. All right, so if it is 60 kilometers, we want to complete this table to show the time that is taken to finish this journey at the different speed. So we have a speed at 15 km per hour, 30 km per hour, and 60 km per hour.
You know, Richard, I like this scenario because it's very practical, because I can think, if I'm traveling and I'm going to complete 60 kilometers and I'm traveling at 15 kilometers per hour.
All right.
So the first 15
The first
hour is 15 kilometers.
Yes.
Second hour, another 15,
Yeah.
I go on 30.
Okay.
Third hour, another 15.
Go ahead.
45. And the last hour here, 15 more, 60. That sounds like 4 hours.
You're correct.
Boy, I don't like those long journey, but let's
All right.
go. And
Let's increase the speed.
yeah.
Let's
We're
go
doubling the
30.
speed. 30.
Yes.
That
long?
sounds like 2 hours, Richard, because 13 1 hour and 30 again.
You're
I feel right.
Go right ahead.
And of course, 60 kilometers
It's only an hour that would take
would
here.
only take us 1 hour.
So what have we noticed here, Karima?
Well, personally, I am noticing, Richard, and I hope students in TV land are noticing the same thing that we are seeing. I am seeing that when the speed has been doubled,
Thank you. What happens?
I am seeing that it takes half the time.
Oh,
so when the
interesting.
15 doubled, and we got to 30,
Yes.
we didn't take 4 hours anymore.
Not at
we
all.
actually took half the time,
Okay.
which is 2 hours.
Good,
And I'm
good.
seeing that. But you know, I want to examine the relationship between speed and time
All right.
a little bit closer. Because
All right.
there's something else I want to come out right here, son. I want my students, I don't want to lose them. I want them to look, listen up, look at the table. And the question is, Richard, you can answer this one.
Okay.
What happens when we multiply speed
By time.
taken?
Lovely. We get the distance. So
But what's happening? Multiply it out for me, man.
So if we're getting the distance, if we're going at 15 km and we've taken 4 hours, we'll cover the distance of 60 kilometers.
So you're saying to me that 15 multiplied by 4
Would
give me
give you
60.
the 60.
All right. Talk to me about 30 and 2 now.
All right, the product is still 60 for each of those two.
You're just rushing the thing. All right, fine, fine. So we found something very interesting now.
Yes.
Because we're noticing that our variables, speed and time, we can call them
They're
X
going
and Y.
almost in an opposite direction.
All right, but we're also noticing that when we multiply them, we're getting the same value. So their product remains constant.
So,
and I'm glad this is coming up on screen that X, Y, or X multiplied by Y
will
is
give you
equal
that
to
constant
K. Good. And K, of course, we said this already, is
will
not equal to zero. All right, and in our case, our K value was 60.
All
so
right.
now
we can answer this question now. So does speed vary inversely as travel time?
That is the big bad question, Richard.
Yes, it is.
That is the big bad question.
And in looking at the previous example, we recognize that as we increase the speed, our travel time decrease. So,
okay.
Yeah.
All right, very good observation. So as the speed increased, travel time decreased, right? And vice versa, we can say, or the opposite is also true. But, Richard, I want to caution our students because we can't just look and say, oh, one is increasing and the other one is decreasing, and so yes, this is inversely proportional. They are increasing. So let's look what's on screen.
the magnitude.
All right, the magnitude, when the magnitude or the size, yes? When the size of one variable increases, the size of the other decreases, and it doesn't stop. Doesn't stop there. It decreases at a rate so that their product
is a constant.
Remains constant. That's important, That is important. So we don't want to miss that point. Students, make sure you get that. So as the size of one variable increases or the magnitude increases, the size or magnitude of the other variable will decrease in such a way that their product is constant. Very important point. So, Richard.
Yeah, man, I'm thinking of
But I don't answer the question. Can you think of a situation? Not because you peep on my screen. Can you think of a situation in which variables are inversely proportional?
Yeah, man, I was just about to bring that up. That, the light source and the distance. So,
light and distance.
So it depends on our distance from a light source, if we are bright or dimmer. So the closer you are to a light source, the brighter you will appear, and the further you are from that light source, you recognize you're going more into darkness.
All right, that sounds like it. That sounds perfectly correct. And that image on screen just does justice to what we just said.
Exactly what we're saying.
Yes. So students, point is, real life situations are out there that model everything that we learn in math. All right, so let's pretty up the language now, Richard. Let's pretty up the language.
All right.
So once we see this relationship, we can say that Y varies
directly as
directly, Richard, I'm going to give you a knock. Let's check. Let's come
inversely.
again. So Y varies inversely
as
X. Or we can say indirectly. I think that's what you wanted to say,
Yes, I wanted to say that Y is indirectly proportional.
All right, so that's another way we can say it. Y is inversely proportional to X.
Yes.
All right, so let's get our symbols correct. How do we represent this? So we fix up the language, and we know we have to go to the symbol part now. We are already familiar with these.
Yeah, we're familiar.
This sign.
The sign is there, so Y is directly proportional to the inverse or the reciprocal of X.
All right.
Or we can say that Y is the multiplied by a constant times the reciprocal of X.
All right. So Y is proportional to the reciprocal of X, and that's a very big word. So let me see if we can break that down. Reciprocal, students, of X, the reciprocal of X simply means we are dividing 1 by X. So it's 1 divided by X. No big deal, all right? So that's what we mean when we say reciprocal. So Y, therefore, is equal to a constant multiplied by the reciprocal of X. And I know my students know how to multiply K along with that fraction.
So we have
1 divided by x. And that will definitely give us y is equal to k
over x
divided by x. And of course, Richard, I know you want to bring this home about k.
K is not equal to 0.
K is not equal to 0. Thank you. I know that's your thing. All right. And so I know, too, that my students will see that if we multiply through by x, we will actually end up with x multiplied by y, giving us
k,
the constant. And we would have seen that because we did multiply speed with the time, and we got that same
constant.
60. All right. I think we're ready for an example of this.
Let's look at the next example coming up. All right, so time that is required to empty a small tank, it varies inversely as the rate of pumping. All right, so if a tank empties in 5 minutes at a rate of 400 liters per minute, how long will it take to empty a similar tank at a rate of 1,000 liters per minute?
Wow, that's a lot of words. So let's see if we can paraphrase this a little bit.
Let's use a diagram. I think it would be better if we use a diagram or something.
Yeah, but we'll come into the diagram. But, you know, think about it. If you have a tank and you're emptying it, yeah? Think about if you have 400 liters coming out per minute, yeah? And it takes 5 minutes. What happens if you have 1,000 liters coming out per minute? Will it take more time, less time?
I don't believe it should take more time. I believe it should take less time.
Because it's flowing out faster.
Much faster.
Yeah, so a lot of words, but that's really what it is saying.
Yes.
All right? And as you rightly said, Richard, we want to bring this up on a table because we know diagrams help us to see things a little clearer. So let's zoom in on our table. So we have our time in minutes, which is represented by t. And we know that it's 5 minutes, and the rate was 400 liters per minute. Now, they already told us that the relationship is inverse, remember?
Yes, it is.
All right, so we already know that t, therefore, is proportional to the reciprocal of r.
R at this case.
Good, so 1 divided by r. We also know that means t is equal to a constant k divided by r. You know, Richard, I think my students can substitute. So I won't even spend too much time right here, so.
Okay.
But I see that the substituting. Did you substitute correctly, students? I hope you did. So we have our 5 right there for our t, and we have our 400 right there for our r.
Okay.
And I also know that you know that we can multiply through by 400. And we will get that k is equal to 400 multiplied by 5.
All right.
And that gives us what, Richard?
It is 2,000.
2,000. I want to pause here.
All right.
I want to pause here because I want you to see what's happening. Remember, we said x multiplied by y must give us the constant. And in this case, we're using t and r. Do you see that t, we multiplied it by r, and it gave us the constant?
Right off the bat.
Oh my God, this is so interesting. So 5 multiplied by 400 does give us the k value. Let's run on. So we know k is 2,000.
All right, so we can just use that value and substitute it right off the bat.
Beautiful. So we know t is equal to 2,000 divided by r. Now in the second case, we have our r value, but we don't know what t is.
Okay.
But I'm sure we can figure that out.
Our
budding mathematicians can figure that out. So let's do some quick substitutions here. So t is equal to 2,000 divided by 1,000.
And so we end up with
a time of 2
minutes.
Right, 2 minutes. There we go. There we go. I feel accomplished.
All right. I believe, Karima, that we can look at some examples just to determine if they are direct or inverse.
I think we should do something like that.
Let's do that.
All right, go ahead, Richard.
All right, so now the first example that we have here, students, we have 4 persons can paint a fence in 3 hours. How long will it take 6 persons to paint a fence? And that's a similar fence. Now, Karima, I recognize we have increased the number of persons, so do you think that we're going to increase the number of time?
let's see what our students think. Let's give them 5 seconds. Let's count down. Don't know if these are literal seconds, but let's count down.
3, 2, 1. All right?
Inverse. I hear them, you know? I hear them.
Yes, I heard them.
Inverse, yes, inverse. Let's look at the second one.
All right.
2 persons can complete a job in 10 minutes. How many similar jobs can they complete in an hour? Let's do the countdown again. Did you get it?
Yes.
Countdown.
5, 4, 3, 2, 1. It's a direct.
That's right. Direct. If you said direct, you are so correct. Yes. Oh, that rhymes. Oh, my. Let's look at the third one.
All right. So 3 workers build a wall in 12 hours. How long will it take 6 equally productive workers to build a similar wall?
You know, this one reminds me about the speed and time that we did earlier.
Yes, it does.
So 3 workers, and we double it now to 6. I'm thinking that the time is going to be half. So
agree.
that sounds like
Inverse.
Yes,
inverse. Our students got it. Yes.
Thumbs up, guys. Thumbs up. You're doing an awesome job.
All right. Let's recap a bit. Now, as it relates for direct proportionality versus inverse. Now, the symbol is important. So when we're reading it, it says A is directly proportional to B, or A is proportional to B. Remember the symbol, students? It basically means that A is equal to some constant being multiplied by B.
All right. And inverse proportion. So we are putting both of them on screen now so you get the difference. If A is inversely proportional to B, what are we saying? A is proportional to, yes, you got it, the reciprocal of B. And what we said reciprocal mean again? Yes, 1 divided by B. So therefore, A is equal to K, some constant, we know, multiplied by the reciprocal of B. So therefore, A is equal to K divided by B. Beautiful. I think they get it, you know.
Yes,
so as we are winding down, Richard, it's important that we look at a CSEC question.
All right, students,
yes,
I want you to take a picture of this question. Make sure that you have it, because as we go through, all right.
All right, so did you get that picture? I hope you did, because we're going to be answering these questions in 5 minutes. All right, so if P varies inversely as the square of V, wow, use the letters P, V, and K to form an equation connecting the quantities P and V. That's the first part. Part B. Given that V is equal to 3, when P is equal to 4, determine the positive value of V when P is equal to 1. And this question is coming from 2019 paper, Richard.
Yes.
So let's see if we can jump right into it.
All right, let's use the symbol, students.
All right.
So right off the bat, we have P is equal to some constant K being divided by V squared.
All right, so note, students, this question said P varies inversely as the square of V. That's important. So P is equal to K divided by the square of V. Right, Richard?
Right.
Very important. All right, now they gave us some values. They gave us P being 4 and V was 3. Yes? And so we need to find, oops, there's a typo error here.
Yes.
My apology.
All right, go on.
So that should be 3 squared, students. So just make a note of that. Typographical error, sorry. Now we substitute our values. P is 4 and V is 3. All right. Therefore, we know that 4 is equal to K divided by 9. All right. I hope our students made that correction. Good. Now we can see here that we will multiply through by 9.
To get that constant value.
And we will get that constant value. Beautiful. And what's the constant, Richard?
36.
36 is so correct.
All right, students. Yes.
So now we know the equation we're working with. Talk to me about the equation, Richard.
All right, so since we know what the constant is, it's 36, so we're going to be finding P which is equal to 36 being divided by the square of V.
All right. But they gave us a value, didn't they?
They did.
Yeah, man, they gave us a value. They said that P was equal to 1.
Yes.
So we can do a quick substitution right here. So when I substitute 1, 1 is equal to 36 divided by V square. Therefore, if I multiply through by V square, I know that V square is equal to 36. How am I going to find V? Because they didn't ask me about V square.
Okay. Our bright students in TV land know exactly what to do. So they're just going to just find the square root of both sides.
Right. Why didn't I think of that?
All right.
Right. So we find the square root of 36. And we see that V is equal to 6. I want to point out here, Richard, because I don't want our students to miss this. We know that if we were to square a negative 6, we would still get 36, you know, Richard.
Yes, we would.
So how do I know that this answer is supposed to be 6? If we look back at the question, and I hope you students took that picture, it asked us for the positive value of V. So we know that V would be 6 and not negative 6. Good.
All right.
You realize that? We just did a CSEC question.
We did.
Oh my goodness, students. Did you get that? We just did a CSEC question. So we're going to put one up for you. Take that picture and that will be your homework. Ensure you complete it. Ensure you complete it. It's a CSEC question and it comes from 2007 January paper. Did you get that picture? I hope you did. So, Richard, I also want our students to take this picture as well. We brought it up before, but we're bringing it up again because it summarizes all that we have said this morning. Students, ensure you capture this.
Yes, and remember, all of this information should be second nature to you whenever you're answering a question involving direct proportional or inverse proportional. So now that's it for today's lesson. We hope that we have helped you to better understand the topic.